one thing you appreciate is the difference between problems like this and problems like this. Here, you start with the inverse. So what you focus on is the domain. It's like for sine. If I were to talk about inverse sine, the domain of inverse sine is -1 to 1. The is e to the power of 2. Okay? So what I'm saying here, domain, then it can only accept numbers in the domain, which is -1 to 1. So I told you before, the inverse sine isn't truly the inverse of the original sine functions. They act like inverses. They only cancel out if the value is within these boundaries. Now, so I'm saying though, if you're talking about starting with the trig function, then you're focusing on the domain, and as long as the number is within the domain, it just cancels and you treat them like inverses. On these problems, now you focus, because you end with the inverse. By the way, what could you plug into this? What is the domain of a normal sine function? Good. But I want you to, here, you can plug in anything. It's going to come the answer. It's just that the answer won't match the input unless you're within this restriction. Okay? Because the inverse can produce any answer. It can only produce angles within this range. Up here, by the way, if you try to plug in something that's outside the function end of sine, except for those numbers in the domain. So if you try to do inverse sine of 2, it's impossible. It fails. It's 10 to 5. Whereas here, you did sine of, I don't know, 3,000 degrees. You'd end up somewhere in the circle, and you have a value, and then inverse sine produce some answer. It just wouldn't be 3,000 degrees because that's way beyond 90 degrees. Okay, so there's two fundamentally different kinds of problems here. All right, now look, let's start doing some of these. Now you don't have this. What is sine of pi over 6? 1/2. Yes. For sure. Okay. So inverse sine of 1/2. Pi over 6. Okay. Now these problems you could just do by actually doing the math like we just said. Inverse sine of 1/2 over 6. So the insides becomes pi over 6, and then sine of pi over 6 is 1/2. And here if you do the same thing, you get 1/2 right here in pi over 6. Inverse sine of 1/2 pi over 6. But I don't want you to be thinking that way unless you have to. I say it that way because, look, they're the same function. So they might just cancel out. Will cancel as long as, like here, once again, we're starting with the inverse. You want to focus on the domain. This number in the domain. So the answer is simply 1/2. It works like that, as long as it's within restrictions. Here we end with the inverse. We want to put out. Is this input something the inverse can produce? It's some less than 1/2. So once again, you can just treat it like inverses. Okay, those are the nice, easy problems. What if I talk something like this? Let's say I did inverse sine of sine. Oh, let's say 5 power 6. Well, now the answer can't be 5 power 6 because that's more than 1/2, and inverse sine can't produce an answer that big. We'll do problems like, well, here, I'll do it real quick. 5 power 6 is second quadrant. Sine is what's sine is what sign? Positive, yes? It's positive. Like, it goes like that. But we can't do any of these. It only goes first or fourth. In this case, first. And second sine is positive. So the answer must come from the reverse quadrant, which is where sine is positive. So it's just pi over 6. And don't worry, we'll practice that more. But you can see it's different. You can't just treat it like inverses if it's outside the restriction. Now just watch. Here, we're focused on the range. The range now is 0 to pi for cosine. And so this wouldn't work for sine, but it does for cosine because it goes up to 1 pi, and that's less than 1 pi, so it works. Here, the domain is -1 for sine. So as long as it's not like 1.3 or 2.3, you're fine. So it just cancels. Here, it doesn't work because, once again, this is bigger than 1 pi, so the inverse cannot put the answer as being 7.5 over 6. This answer came from doing this. Watch this. Which is this actual angle in? third, right? And cosine is positive on the right, negative on the left. So our answer has to come first or second, from first or second quadrants. It's going to come from second, because that's the other place where cosine is negative. And the reference angle is pi over 6, so that's where the came from. So we'll do more examples like that. For now, the biggest thing you get is that up here, they just cancel. You can treat them like inverses, whereas here it was harder. And you can't treat them like inverses because the value given is outside the restriction. It's outside 0 to pi. All right, now, we're on all starting with the inverse. So what should I focus on? The domain or the range of the inverse? The domain. Actually say, okay, what can I plug into that function? And only things between 1 and 1 can be plugged in. And so, here, get that out of the way. And so this does fall within that domain, so it works. So it's like that. This one doesn't. And listen, if it's not in the domain, the function is not defined for that input. That means it's not undefined. It has no value. You can't even start. And so if I just ask, what is inverse 5, for instance? It's a non-starter. It's inside of something else. You don't even get to this part. It doesn't matter, I'm saying, because you can't even start the problem. What about the next one? Is square root of 2 over 2 less than 1? Yeah, so it just cancels. This, of course, you could have actually worked through the problem. It is inverse sine of square root of 2 over 2. It's in the middle of the first quadrant. Pi over 4. So you say, oh, well, that gives you pi over 4. And then sine of 4 is square root of 2 over 2. You could do that work. Same answer, but once again, up here you couldn't. So I want you to get how to use these restrictions. Next one, is this number between negative 1 and 1? Yes. But the next one, no. It's less than negative 1, isn't it? So that's a fail. You can't even start the problem. The function is not defined. Now, look at these. It's different. When I say starting at the beginning, here the inverse was on the inside, so we'd start with that. Now it's in the outside. It's the outer function, so we'd end with that. It's what produces, and it can only produce the answer with this range. So, but look, normal sine can take any answer as an input. I'm saying these functions will all have answers. They'll never be undefined. The domain of sine is all real numbers. So let's do all the ones where the answer matches the input. And so is pi over 8 with an answer that inverse sine can produce? Yes, that is the answer. Is 3 pi over 4 an answer inverse sine can produce? No, so let's skip that one for now. Is this one within the restriction? 4.5 ninths, which is exactly a half. So yes, this does fall. So they just cancel out. Up here, you can just treat them like inverses. This one, you got to be careful. This is less than half pi. It's more than 1/2 radians. But here, somewhere on your paper it has the restrictions listed, doesn't it? I would write them as decimals as well. A half pi is 1.57 radians. Remember that? Well, radians is less than 1.57 radians, so it is within the restriction, so it works. The last one obviously works. Negative 1 is obviously between negative 1/2 and positive 1/2. So that's the easy kind of problem. This one is trickier. Picture. That angle is third, right? 3/4, middle of the third quadrant. Sine is what? Right? Now the answer can't come from the second quadrant because the answer can only come from first or fourth. In this case, which will it be, first or fourth? First, because it's positive and sine is positive first. It wouldn't be fourth. So what's the answer? Must be a first quadrant angle with the same reference angle. So pi over 4. Done. This one, just for the record, you could actually just work through the problem. Sine of 3 pi over 4 is here. If I write here, it's negative x, positive y. Here it's positive x, positive y. What I'm saying is, if you 3, you get square root of 2 over 2. And then if you do inverse sine of square root of 2 over 2, though, it's going to give pi over 4. You could actually work through it, like, but you want to use reference angles, it's faster. Switching to cosine now. What do we focus on here? The domain or the range of the inverse? Look, we're starting with the inverse, so we want to focus on what it can take as inverse. And the domain here is the same as it was for sine, so it works the same way. It's number between negative 1 and 1, yes, so it works. This one, no, so it doesn't exist in the domain. This one's a yes, this one's a yes, and this one's a no. So once again, it doesn't exist there. That's easy, it's the same as sine because it has the same domain. Right, so when I get to these, it's totally different because now we're ending with the inverse cosine, and so we focus on the now 0 to pi. So is this number between 0 and pi? Well, certainly. So that works fine. And this one also works now. It was bigger than 1/2 pi when we did cosine, but it's less than 1 pi, so it works. And the next one also will work. Next one, it's decimals. This is 0 to the 3.14, obviously, so it definitely falls in that range. Now this one fails. Remember, it doesn't mean it's undefined. It still can't possibly be negative 1/4. So let's draw a picture. The angle that gave us is the fourth quadrant, right? We're talking about cosine. Cosine's positive there. It goes positive here. So the answer for inverse cosine, the answer is first and second, right? Because we're talking about a positive value. So the answer is simply pi over 4. Questions? Then we're switching to tangent. Once again, we're focusing on the domain of tangent, inverse tangent I mean, is anything, which means these can't fail, which means they all work. You don't even think about it. And literally, if you put like negative, inverse tangent of negative 1 billion, and then do that, you'll get negative 1 billion. The domain is all real numbers, so it'll work. But then when I switch over to the other side, it's going to be different again. Now listen, the restriction on tangent is pretty much the same as it is for sine. So when it works the same way. So pi over 8 works. 3 pi over 4 doesn't work, just like it did work for sine. It's bigger. This one does work, so just treat it like inverses, they just cancel. It's less than 1 again, so it works. And the bottom one also works. This one though, we have to work it out. Let's draw a picture. 3 pi over 4, second quadrant. Is tangent positive or negative in the second quadrant? And see, that's the difference. Sine, when we did sine. So now tangent's negative in that quadrant, and which other quadrant? And inverse tangent only produces the answers from first or fourth, so it must be fourth. So how's the answer expressed? It references pi over 4. Yeah, there you go. The fourth quadrant angle pi. And now we mix up. So right now, number one on this, do we want to focus on the domain or range of inverse cosine? We're ending with the inverse, so we want to focus on the range of it, which is 0 to pi. Can the inverse produce as an answer? Yes. So that is the answer. Okay, let me just say, right now we're just focusing, we're doing like cosine of inverse cosine, where the functions match, so they might be inverses. The unfortunate thing is there's a lot of different kinds of problems. Later on, we'll mix up the functions where it's totally different. Then you obviously aren't just going to cancel on problems like these. Okay, so, but right now, our first question is, does it just cancel out? Here, you should be focused on the domain, because we start with the inverse. That does fall in the domain, so yes, you just cancel out. The answer is negative 0.4. You're done. Easy. Next one, you focus on what? Domain or range? No, we're back to ending with because. So the range is 0 to pi, so was it yes or is it no? Because that infant's big pi, it can't be out. And actually it would be 5 pi over 6. 7 pi over 6 is third. Cosine is negative. And 5 pi over 6 is the answer. But you didn't answer that. All right, next one. Change this time of inverse sine. What's the sign? Negative pi over 2 to pi over 2. Yes or no? Does it work? Too big. It's bigger than half, so that's a no. Here, you're still focused on the range. Well, 2 is bigger than 1.57, isn't it? So that's a no. And then here, you're still focused on the range. 1 is less than 1.57. That's yes. Now you're focused on the domain. Because you're starting with the inverse. What's the domain of inverse sine? No, just negative 1 to 1. So that's a no. Now just watch for a second. Here, I'm just going to problem here. What if I made it like 1.4? Right now we're focused on the range. Is this number within the range? Yes. So that would work. If I reverse it and did sine of inverse sine of 1.4. Okay, that's fail. Now we're talking about the domain, which is negative 1 to 1. So that'd be a no. So I guess this would be yes. It would work. This one, we're not going to phrase it as yes or no question. All right. Here, actually, I have to find the answer. And once again, the answer can't be 5 pi over 4 because it can't be over half pi. Which quadrant are we in? Third, middle third. The answer must come from the fourth quadrant. So what's the answer? Yeah. Okay. Now this next, change it on your paper. It should be denominator of 2. Okay. Well, it's not hard. You just work. What is the inverse sine of negative square root of 3 over 2? Okay, it's a negative, so it must be a second quadrant angle. What's the reference angle? Pi over 6, right? But at pi over 6, your coordinates look like this. So we're definitely no pi over 6. But over here in the second quadrant, here's our angle. And I would write this down. Draw the second quadrant, at least. So like I said, this produces 5 pi over 6. And then you're figuring out cotangent of 5 pi over 6. Well, the coordinates are right here. Cotangent is x over y. So what do you get? Just square root of 3 over 1 was square root of 3. Negative square root of 3. So just work through it. Cosine produces, and then do cotangent of the angle. Next one. What's the reference angle? Where's cotangent equal to that? Pi over 6 or pi over 3? Pi over 6. Remember, tangent values go 0, then square root of 3 over 3, and then 1. So this is going to produce pi over 6 as an answer. That's what inverse tangent would produce. Let me call that real quick. It'll be here. Hold on, let me do it right. Positive x, negative y. Okay. What's the answer? Cosecant is a reciprocal sine. So what's the reciprocal of that? Okay. Okay. And then things change. Because we know where sine is 1/2 and cosine is 1/2. We don't know where tangent is 1/2. Tangent can produce any value. Okay. Its range is all real numbers. So the inverse has a domain of all real numbers. So that's what I'm saying is it does have an answer. We just don't know where. So we have to change our approach entirely. This one I want to kind of walk you through this, and then we'll do it faster in the next example. What I want to appreciate is that inverse tangent is going to produce some angle as an answer, right? So we don't know what it is. So do this. So it produces some angle. We don't know what it is. I'm not going to worry about what it is. Which quadrant is that angle in, though? Because it's positive, we're doing inverse tangent positive. It must be first quadrant. Sit down. We know we're in first quadrant. We also know that y is and x is 2 because tangents y over x. We're trying to find sine of that same angle. Here, let me do it this way. We basically, it's like this. We're given tangent of some angle is 1/2. We're given that the angle is in quadrant 1, and they're now asking what is sine of that angle. That's the question they're asking basically. We've done it before. It just looks totally different now. And yeah, to find the answer, you have to use the definition of sine, which is pi over r. And so some of you are ahead of me. We need to do Pythagorean theorem because we need r. And it will be square root of 5. Yeah. So over square root of 5, which is square root of 5 over 5, and we are done. Once again, be acutely aware which quadrant you're in. Okay? That's your first thought. Forget about it and get the sign wrong and just get it marked wrong when you do all that work. All this is as important as that. So here, let's do the next one. Which quadrant? Go ahead. Sure. No. But we're talking about what you're given is a tangent. We don't know that. Tangent. What tangent values do we know? We know where tangent is 0, and where tangent is square root of 3 over 3. Where tangent is 1, where tangent is square root of 3. And if it goes from 0 to 1, at some point it crosses 1/2. It equals 1/2, but we don't know what. You know what I'm saying? It's not even a circle problem. If it had been, watch, if it had been tangent of inverse sine of 1/2, that'd be a circle problem because we do know where sine is. Okay, so and I would have done that way. And that's the point. This works on all the problems, but you don't want to do it on all the problems. If you can use the unit circle, then. But here, once again, we can't because we don't know where sine is 1/3. So let's do the same way. Let's just get the information we know. This is going to produce an angle. The angle is in quadrant what? It's inverse sine of a negative. Inverse sine does, fourth or first. In this case, fourth. So write it down. You know you're in quadrant 4. Y over r, I is -1, and r is 3. That's what you know. What you need to produce the answer is x over r because you're asked for cosine of that same angle. All right, so squared plus 1 squared equals the radius squared. It's going to be positive 1, so when you subtract it, you get 8. So x is the square root of 8. With what? What, 2 radical 2? Yeah. Positive or negative? It's coordinates, so it could be positive or negative. If we're in the quadrant, xi's are positive. Okay, so it is a positive, right? But you need to be sure of that. So, fine, x is 2 radical 2, r is -1, -2 radical 2. Okay, I was wrong. Yeah, I'm thinking r is. I sometimes forget to make mistakes. I just, the other periods, I do it intentionally usually. And so, you don't always get the chance to catch my mistakes. Which is not good. How do you know if you're... It's a good catch. Yeah. All right. You try this one. Like, see, I was thinking of this problem. Answer the last one. Now we're doing which is y over x. So yeah, the math is pretty much the same. Once again, it's inverse cosine to start with. Inverse cosine produces answers from for second. It's negative, so that's the second quadrant angle that you deal with. let's back up then. We're starting with inverse cosine, right? It's on the inside, so yes, we're starting with that. First, it's not like we did before because that value is something we don't have memorized. So we have to take a different approach. And like I said, if you do it, and it produces some angle. So another way to say this is that what they gave us is that cosine is that value there. And because it came from the inverse cosine, the angle must be range. And if it's negative, then it must be. For a second, where is cosine negative? Second, third, right? And just for the record, before, when we did a problem like this, they would tell you, first of all, they give you the trig. If all they gave you is that's not enough, though. I need you to appreciate that. The cosine equals this negative value. You don't know which quadrant you're in. So, because it could be either one of these. So before like this, they would give you the value, and they'd give you the quadrant. Now, they give you the value, and you figure out the quadrant. Once again, inverse cosine cannot produce third quadrant answers. You know it can't be a third quadrant. It must be a second quadrant angle. That's where that comes from. And then after that, you just use your definition. Like they gave us line, which is x over r. They're asking for tangent of that same angle, so that's y over x. So you do Pythagorean theorem to find what you did not know, which is y. And then you do y over x, and you're done. Yes. Well, going back to your definitions, and I'm sorry, I kind of went too fast here, apparently. Well, like right here, cosine is defined as x over r. Do this, you say, okay, that must be your value, must be your r value. And so, like I said, it's all about knowing your definitions for like sine, and tangent. But it's all based on the quadrant. And hold on. What? Yeah, can't. And so, but I'm saying, and just that brings up a good point. If I did this, tangent is y over x, right? So the equivalent of saying, we have some angle where tangent equals a negative 1/3. Well, fine, and tangent is y over x. I'm saying, which quadrant are we in here? Well, if you do inverse tangent, it's first or fourth. It reflects on. So you must be in the fourth quadrant in this case. If you're in inverse tangent to get your angle, and inverse tangent is the same as sine. You see what I'm saying? You have to know these. Okay, otherwise you're going to get lost in these. So inverse tangent produces only angles from first to fourth. But that means x was the 3, y was the 1, but which one's positive and which one's negative? Well, you're quadrant 4, it turns out, so it's positive x, negative y. If it had been an old problem where they gave you the tangent value and then said, oh, you were in quadrant 2, well, then the sign would be different, right? But because we're talking about an inverse problem, if it's inverse of a negative, inverse tangent of a negative, the angle must be either first quadrant or fourth quadrant only. In this case, it must be a fourth quadrant angle. We know that. Because it can't be a second quadrant angle. Alright. We're going to move on. You have this one on your paper? Okay. And, hold on, I'm sorry, we got to move on. I know, but let's just finish this. We're almost done. Sine of this one, we just have to work through it. So this is sine of 7 pi over 6. And the reference angle, and draw it. And listen, I would try to do these without a circle in front of you, because frankly on the test you won't have the unit circle in front of you. So here, let me try to draw it legibly. Well, right now, we're just trying to evaluate sine of 7 pi over 6. Okay. Now, like to evaluate this to start with. We got the value. This is kind of weird, frankly. Now you have to figure out inverse cosine of that value. So we're going to inverse. Where is cosine equal to 1/2? It's at pi over 3. Okay? 1/2 there. Now we're talking about the negative 1/2 though. For the inverse, where should I be looking for inverse cosine? Second, fourth. Second, because once again, inverse cosine goes 0 to pi. So draw this picture. And then it's 2 pi over 3. Like I said here, just do it one step at a time. As soon as you do the first step, you find the answer to this, where it came from, and just focus on doing inverse cosine of that value. Just like yesterday's, and figure out the reference angle, figure out the quadrant, and so it must be second quadrant with the reference angle of 3. Let's try the next one. Which quadrant is this angle in? If I draw it, where is it at? Fourth. And sine is the y value. So negative square root of 3 over 2. So in arc cosine just means inverse cosine. I'm just going to rewrite it though. So now we're doing arc cosine of that value. Oh yeah, I'm sorry. I changed it. We needed one like this. Change it on your paper, number 15. Make it so it's sine. We did plenty of inverse problems already. Okay? So we didn't need another inverse problem. Sorry. Forgot to tell you that. Now we're doing arc cosine of an inverse of a negative. Once again, arc cosine does first or second quadrant. The reference angle is pi over 6. Because the coordinates there will be negative square root of 3 over 2, comma 1/2. So what is that second quadrant angle? Yes. You do 1 minus the 6th, that gives you your angle. All right, let's finish this. Here, and I want you to understand, cosecant, just to rewrite it as reciprocal. Reciprocal cosecant is sine. Reciprocal of 2.5. And then, yeah, it's just pi over 6. You do reciprocal and then reciprocal value. Good. See, first period I made that mistake. Second period I forgot to make the mistake. This period I remembered to make the mistake again. You are awake. And then that, of course, is really, when I'm reading that, which means now is right, it is pi over 4. Next one, you do the same thing, but it's clear, obviously. You do the reciprocal function, and then the reciprocal of the value. And of course, like this, to fix it, you multiply by square root of 3, top and bottom. But you just did square root of 3 times square root of 3. What is that? 3? I mean, just that part is 3. I'm just saying, that really just cancels right there. which means it's really just square root of 3 over 2, negative square. And we actually just did that. It's pi over 6 for the reference angle, but it's second, so 5 pi over 6. Now listen, we haven't done the sec and cosecant as much. You know, you're probably listening with those values. So for now, you probably have to actually do the math to figure out what the reciprocal is. But eventually, you just want to memorize. The reciprocal of this is square root of 3 over 2. The reciprocal of this turns out to be a familiar number. Now, cotangent and tangent are different. In other words, up here, secant and cosine have the same restriction. Okay? They both work in the same quadrants. Like sine. Tangent and tangent don't. So actually, I want to add a problem here. We can do both of these. Okay? And listen, tangent and cotangent go positive, negative. They're both 1 right in the middle of every quadrant, or negative 1. So cotangent is the one that goes 0 to pi, just like cosine. So right in the middle of the second quadrant is 3 pi over 4. But tangent works like sine, so it produces answers from first or fourth. So what does that answer? Yes. Okay? So just be careful. All right. Then this last bit. Here it's inverse sine. The reciprocal function. But these are calculator problems. So get a calculator if you didn't already do so. Make sure it's in radian mode and type that in. By the way, inverse sine produces answers between negative pi over 2 and pi over 2, which means your answer should be between negative 1.57 and positive 1.57. It actually should be negative. This is the fourth question answer. What did you get? Negative 0.25? Now, jump down and do this, Bob. Just not exactly, but it is really close. It's that way, actually, when you're close to 0. Here, same way. Just typical function, other reciprocal, type it in. This time it should be first quadrant answer. What did you get? Which is less than 1.57, so it is less than 90 degrees. With cotangent, I told you it's tricky. So here's the deal. There are no buttons for secant and cotangent. Here, secant and sine have the same, so you can just use inverse sine without a hitch, without a same with secant. And, right. Here, though, you got to be careful. Now, inverse cotangent produces answers between 0 and pi, right? So inverse tangent here on this one, you can that it equals inverse tangent of 2. Actually, inverse tangent though produces the answer between negative pi over 2 and pi over 2. So that's not the same expression. But why are they going to do here? Because if it's positive, it's going to be a first quadrant angle. Will they overlap? So type it in. Type in inverse tangent of 2. Okay, is it round to 1.11 or 1? Okay. By the way, well, just type in normal tangent of 1.11. Do it real quick. You get something close to 2. And so that is an angle where tangent equals 2, which means it's an angle where cotangent equals 1/2. That's the correct answer. And it's first quadrant angle, which is something that inverse cotangent can produce. Up here, we're going to do it differently. What I want you to do is off to the side, right, tangent of inverse tangent of the reciprocal. Okay? We don't have a choice but to get the calculator to do that problem for us. It can't be the answer, because we just said inverse tangent produces answers from negative pi over 2 to pi over 2. And this is going to be from the fourth quadrant, which is not something inverse cotangent can produce. So, first of all, what did it give you? negative 0. Now, so that's the answer for this question. Call that the fourth quadrant angle, right? But what's the reference angle? Well, 0.46. So come over here. Here we're talking about where tangent's negative, which is, oh, this is not working very well, first and fourth. Over here, I'm doing cotangent, which is first and second. Saying this had to be a second quadrant angle. Know this. And it had to be a second quadrant angle with the same reference. So put a 0.46 here, the reference angle. So how do you figure this angle now? The reference angle is 0.46. Yeah, subtract from pi. So type that in, use the pi key. Pi minus 0.46. All right, now I want you to do one more thing for me. Go and type in the tangent of negative 0.46. Tangent of negative 0.46. You got something close to negative 1/2? Yes? I'll type in tangent of 2.68. Same thing, right? So these two angles we're dealing with have the same reference angles. They have the same value. They both produce negative 1/2. Okay? But this one was appropriate answer for inverse tangent because it's in the fourth quadrant. This is from the second quadrant. And so that's what you have to do. Get the calculator to give you an answer, but realize it can't be the answer to the question you're trying to answer. That means the calculator's answer isn't the answer to the question. You use it, you get the reference angle from it, and then use that to find the actual answer.